Hi, my name is Amy, and I'd like to welcome you to our webinar today, Traveler Information Messages, or TIMS, Creation, Delivery, and Standards. We have two amazing speakers today. First, Zarisa will kick us off with an introduction and a little bit about TIMS, technology, standards, and how to build TIMS. Then Shane Zumpf will delve into Corvus, a tool to build and disseminate TIMS and situation data exchange and TIMS delivery to vehicles. We're excited to get started, but first I'd like to cover a few housekeeping items. First, all attendees are in listen-only mode. If you have any questions at any point during our time together, feel free to enter those in the Q&A panel in your Teams document. We'll save a few minutes at the end for Q&A after our speakers have presented. If we don't get to your questions during our time together, we'll be sure and answer them via email after the webinar. This webinar is being recorded. The recording will be available after today's webinar. Finally, you'll have an opportunity to complete a short survey at the end of the webinar. It should only take just a minute, and if you would kindly do that for us, it helps us to create valuable webinar experiences for you in the future. With that, I'll go ahead and introduce our speakers. First off, Zarisa guides organizations in connected vehicle applications. Leveraging her PhD in transportation engineering, she is active in transportation committees, which include TRB and ITE, and focuses on developing customized CV systems. Next, we have Shane, who has over 25 years experience in the information technology field. He serves as a technical lead responsible for software architecture and overseeing application development and implementation strategies for various CV projects nationwide, including just completed the Wyoming Department of Transportation Connected Vehicle Pilot Project. With that, I'll turn it over to Zarita.
Thank you, Amy, for the introduction, and hello, everyone. Thanks for joining our webinar. Next slide, please. Okay. So before we dive into details, I would like to quickly walk you through today's agenda to give you an overview of the key topics we will be covering. We will start with an introduction to travel information messages, commonly known as TIMS, discussing their importance for traffic safety. From there, we will move to technology that is used to disseminate TIMS, especially in vehicle delivery. Then we will cover criteria for creating effective TIMS. That includes considerations around data, standards, and security protocols. And in the end, Shane will provide an overview of Corvus and situation data exchange, with also demo of Corvus. And both of these applications are developed to support the creation and dissemination of travel information messages. So what are the travel information messages? They deliver crucial real-time information to drivers about changes in road conditions or other safety-related updates. And as we see more and more connected vehicle deployments, we can say that they are also geofenced connected vehicle safety messages, as they are a key tool to enhance communication between drivers and infrastructure. These geofenced standardized messages are capable of providing precise, location-based, and real-time information to drivers. TIMS can communicate a very wide range of alerts, including traffic conditions such as congestion, incidents, road closures, weather updates, construction zones, notifying drivers about changes in speed limits, lane availability, or presence of workers. TIMS also play a key role in sharing emergency alerts, such as those for natural disasters or other events that are affecting road safety and accessibility of those roads. And TIMS are very versatile and can be tailored to address region-specific challenges, whether it is snow in one area, flooding and hurricanes, or sandstorms in another. And exactly this flexibility that the TIMS provide ensures that drivers receive relevant localized information that support safer driving behavior and potentially reducing a crash risk. For example, a team alerting drivers of an incident can help prevent secondary crashes and protect both road users and first responders. Beyond safety, travel information messages also support traffic management and help agencies reduce congestion, especially around closures in work zones. And as a part of broader traffic management system, teams integrate with other systems such as incident management, weather management, traffic signal coordination, and any other that's necessary to support these strategies that are defined for an agency. And I think 2 or 3 days ago, there was a very great article by ITS JPO that highlighted the importance of travel information messages to address severe weather conditions and how those alerts can improve safety. Next slide, please. So the concept of travel information messages is not new. For over 2 decades, federal and state agencies have used systems like 511 and dynamic message signs. So 511 system is now widely available. I believe almost all states have it, maybe a couple of them not yet. And 511 provide essential road condition information. But it is more suited to be used for pre-trip planning rather than real-time updates while driving, as using this on road can pose safety risk from distractions. On the other hand, dynamic message signs provide real-time updates in road conditions without really causing distractions, but they are limited by their fixed locations and restricted geofencing capabilities. So to enhance benefits of both of these systems, but also to address challenges, we have connected vehicles that can enhance and enable in-vehicle travel information messages to provide real-time updates without requiring drivers to interact with any device and reducing distraction risk. Although still is in development for most of the country, some states like Wyoming have already successfully demonstrated travel information message system using connected vehicle technology. So we just said how beneficial in-vehicle travel information messages could be to improve safety, but how can we ensure the drivers really receive accurate and timely information in their vehicles without overwhelming them with so many information and providing that information in format that they get used to seeing it? So to effectively deliver teams, several criteria need to be met. That includes appropriate technology, high quality input data, established standards, and very robust security measurements. And I will cover each of these separately in the following slides. So I mentioned technology at the first place, and what kind of technology we can use to deliver in-vehicle teams. At the first place, that's connected vehicles based on CV2X or cellular vehicle-to-everything communication, which requires robust roadside infrastructure in vehicles that are equipped with onboard units. While deploying this technology on a bigger scale can be really challenging, it also has some advantages over other technologies, including the ability to support other safety messages besides Teams, and especially those that are time sensitive. Other options for in-vehicle team delivery are third-party services that already exist and that are already in use. Those are navigation apps, radios, infotainment systems, and they can communicate travel information messages using satellite or cellular networks. And these third-party technologies are especially useful in remote and rural areas where deploying CV2X is difficult and sometimes even impossible. However, for agencies to employ and use third-party services, they need to have data exchange platform to manage that communication between communication with third parties. And one example of such a platform is Situation Data Exchange that allows agencies to send teams to third parties for in-vehicle broadcasting. And Shane will touch a little bit more based on that in the end of the presentation. So we just talked about importance of technology, and now let's focus on the quality of data for teams. And how confident are you in your data as a state agency? So the reason why I'm asking this question is that the main point and thing with travel information messages is to provide accurate and timely information to drivers that can positively impact their behavior. And we also know how hard it is to gain the trust of drivers that they can rely on the system, and that any unreliable alert actually can make drivers lose trust in the system. But the quality of data that is used in travel information messages depend on several criteria, and some of them are data source, data accuracy and reliability, data timeliness, data format and readiness to be used for travel information messages. Most of data for teams are coming from Advanced Transportation Management System, ATMS, and that data is already checked and confirmed as trustworthy. But all that process will take some time, so sometimes can even create delays, and maybe that information is not going to be valuable for drivers anymore once when it's pushed out to vehicles. So additional data that can be used besides ATMS is coming from third parties. That's crowdsourced information, connected vehicles data from basic safety messages, or directly from origin equipment manufacturers. And many of these sources are reliable, and some of them are real time, some of them could be a little delayed, but either way, it's always recommended to cross-check information from multiple independent sources. And this procedure can take a lot of effort from TMC operators to provide those useful and on-time teams. So to move forward, let's see what's needed to be considered when creating a team. So we just mentioned technology and data sources, and how important it is to have established a process to gather, verify, and format information before they go out, and how that could be really hard for agencies, especially those that have limited personnel, to manually verify each piece of information. And that's actually where automation is coming to help in to reduce the effort that operators need to put out to provide teams. And there are several tools that can help to create and manage travel information messages. One of them is CORVUS that we will speak about a little bit more later. But regardless of the way how teams are created, either manually or automatically, they still need to follow established standards to ensure nationwide interoperability. And in the next slide, I will speak more about standards and which standards need to be considered when we are working on teams. Another criteria that need to be checked is security. Every travel information message exchange between infrastructure and vehicles need to be properly signed. This is achieved using a security credential management system. You probably heard of that as a SEMS, and that's provide the digital signature that's required to secure communication on both ends, either infrastructure and vehicles. And that also ensures when an OBU or other device in vehicle receives a message to know that message is coming from a trusted source. In the end, considering the technology is constantly changing and evolving and standards as well, it's always recommended to stay connected with the community and look and adapt the best practices in this process. So let's move to the next slide and review the specific standard and best practices in that. I know that I mentioned the standard several times, and now I'm going to explain why it's so important. At the first place, following standards ensures the consistent, reliable communication with drivers across different systems, different regions, different devices. In one word, it's provide interoperability. So for those that are experienced with a dynamic message sign operation, at first it may look the same, considering that in-vehicle teams very often display similar information to the physical signs and dynamic message signs, but in background, they operate under a distinct set of standards that support the digital formats. And teams also can support different type of messages, as we discussed before, but that also could be message regulatory warning or temporary traffic control messages. And the standards that we need to pay attention are SAE J2735, which is a V2X communication message set dictionary. This is the base and defines how data is structured and transferred between different systems, including dialogues, messages, data frames, and elements. Another important standard that also help prevent different interpretations and displays of teams is SAE J2540-2. This standard is known as International Travel Information Systems, or ITIS phrase list. And this standard specifies message content and phrasing. So while this standard also includes a recommendation for display in vehicles based on MUTCD guide manual. Though that's in the end is decision of the deployers and broadcasters. And for those phrases that are not linked to any MUTCD signs, it's still recommended to follow at least those base recommendations, such as colors that are reserved for regulatory or warning signs or work zones. And also when providing geofence extent for travel information messages, it's always recommended to check if MUTCD provides similar guidance that can be applicable to a particular team. Next slide, please. So our experience here in Trihydro, working with agencies on travel information message development and deployment, and as well based on the insights from the recent US DOT interoperability testing that was in Cheyenne, Wyoming, sometime beginning in October, there were identified several criteria that are necessary to follow when we speak about travel information interoperability between different regions and different onboard unit manufacturers. In the first place, that adherence to standards. Following established standards like those that are mentioned in the previous slide, and special attention on adopting the best practice for message elements, those that are optional in J2735. And I will just list several of those elements. First place, that's a unique message identification that ensures that messages can be updated or deleted as needed, but also prevent message duplicate. At another place, it's a data frames that determining when using more than one data frame in a travel information message is appropriate, and ensuring that all OBUs are capable of receiving and displaying those messages. Also, message type definition, ensuring that that message is displayed in vehicle on the way as it is intended. For example, if it's created as a regulatory message, to make sure that it's really displayed as a regulatory, not as a warning message. And besides these elements, it's also important to have a national-wide consensus on Teams implementation. And that includes implementation conditions, defining when a specific team should be created and broadcasted. What are those conditions that trigger certain team? Then there is a phrase standardization that we already mentioned through ITIS standards to make sure that everyone is using the same phrase for the same conditions. In the end, those are the timing and geofence. While timing and geofence can be slightly different depending on the event and location, we still want to try to be as consistent. And that way, make sure that drivers are having a same or almost the same experience, regardless of a location where they are and which state it is. Next slide. So here we have a graphic example on how teams are delivered to vehicles. Those green spots represent roadside units that are installed on the section of the road between Laramie and Cheyenne. And once an event happens, traffic management center that is in Cheyenne receives that information and create travel information messages that are further delivered to roadside units in that that travel direction. I would say from in this case that's westbound. So once a vehicle is traveling toward those roadside units and passing, vehicle will receive those information, but the message will not be displayed in vehicle until the vehicle reach the point where the geofence of the certain team starts. And here we also have example how team may look like in a vehicle. This is from our testing that was conducted several years ago. So if messages are broadcasted to third parties, this will work on the same way, except that they are going to be available even in areas where there is no roadside units. And now Shane will discuss more on CORVUS and SDX and how they can address challenges that agencies are facing in deploying and creating travel information messages.
Mute button there. Thank you very much, Sarita. Let's see. For Tim creation, and really Sarita did a good job of going over what certain things you need to consider when developing a traveler information message and deploying a traveler information message out onto the roadway. Now we're going to look a little bit at how you can actually integrate these into your systems and be able to deploy these in a production environment. And really, there's a couple of different paths that you can take here. There is an open source path available for being able to develop and deploy TIMs out onto the roads. And then we have Corvus that I'll demonstrate. And this is really a system that we built out based on our previous experience in building out these open source environments in particular for the Wyoming DOT's Connected Vehicle Pilot Project, but also with our work with Colorado and other state agencies. So first off, the open source path. And I don't want to discount this path. It is a great path for state agency to take, as long as they have a lot of in-house expertise and ability to want to customize their deployments for their particular systems. Now, this is sort of an architecture diagram of an open source deployment in Wyoming. And there's a couple of key components in here, including the operational data environment and the data broker. There's a lot of custom software development that took place in this deployment, as well as really a lot of deployment and server resources that are needed with these deployments into state agencies. So those are just some things to consider if you would like to do an open source deployment. All of this really does take place with with the knowledge that you have to have developers in place that are capable of building out systems that can automate the creation and management of your traveler information messages. That's not really a given as far as ways to be able to push those out there. Not all of that is actually in the open source deployment. Some of that's custom software that you have to integrate with your existing systems in there, including your 511 system. In this case, Wyoming has separate systems for their incident management as well as construction administration. So this is just one scenario where if you have the in-house expertise or want to do something that's specific to your environment, you can. It does require a lot of additional resources, though. So what about the Corvus solution that we've built out? And this I'll get into a little bit of a demo here in just a bit. But Corvus is the application that we built out to be able to effectively manage these same applications and deploy it into an environment that, rapidly deploy into a new environment at substantial probably cost savings as opposed to the open source deployment. This really does save us time, money, effort, and using a system that's cloud-based. So really, it's what I like to refer to as CV messaging in the cloud. And we have this system that you can actually do manual deployments of, as well as fully automate. So let's see. Really, the deployed system looks a lot like this. We've got a traffic management center. We have a small, lightweight application that we deploy onto infrastructure within the DOT environment. We do that for a couple of reasons. We want to be able to talk to your 511 systems or your ATMS systems, all of those systems that are internal to your network and you don't want to expose externally. We want to be able to integrate those. And we really did that based on a lot of comments that we've received from different folks at IOOs where you're really talking about wanting to have TMC operators not have to do additional tasks, right? We don't want to add to their plate. We want to be able to integrate with those existing systems while at the same time enabling a connected vehicle environment. So we deploy a small lightweight thing out onto the infrastructure within the DOT to be able to integrate with those systems, but also to be able to deploy those same connected vehicle messages to our roadside units. Those roadside units are then broadcast those messages like Zoritsa was going through earlier. But we also are able to then integrate with the situation data exchange too on an external system. So we have a small lightweight component that lives within the environment that really talks to the cloud hosted Corvus environment. And we'll get into a quick demo of that. The Corvus environment on the website side does allow for manual creation of TIMs. And that manual creation of TIMs is fairly easy as far as that's concerned. It's something that we built in there probably more for emergency or demonstration purposes more than anything else. This system is really built out to be an automated system. Again, the data sources on the inside include the ATMS as well as third-party apps. We're looking at partnering with a bunch of different agencies to be able to integrate with their systems into the Corvus system, really be able to enable a connected vehicle environment for many different inputs. We also have a data analysis component of Corvus, and this is one of the things that we're really excited about being able to deploy, is really integrating artificial intelligence into our system so that we can validate and accurately display traveler information messages. So what that really means is when Wyoming, say, deploys a snow traveler information message for a particular road segment, and we detect and we read in that your RWIS stations in that same area are detecting 80-degree weather, and we look at the actual webcam images that are showing clear conditions, that we may want to flag that message as being invalid, and then either go back to the traffic management center and say, are you sure you want to deploy this? Or just pull that traveler information message off of the deployment. In other words, we want to be able to streamline the validation of these messages as much as possible, but also double check and make sure that traffic management centers are deploying messages that the public can trust. Going back to what Zaritza was saying earlier, the second that we start deploying messages where the public can't trust it, they're going to start ignoring it. So we need to make sure that we're doing as much as possible to deploy accurate messaging. Another thing that Corvus integrates with is really the security credential management system. We partner with a couple of SCMS providers and integrate with those systems to be able to sign the connected vehicle messages prior to deployment to both roadside units as well as the situation data exchange. And really what that does is signing those messages with the SCMS system enables receivers of those messages, so drivers or vehicles, to be able to validate those messages as being coming from a trusted source that is essentially validates that message as being valid and secure. And then on the message dissemination side of things, Corvus does integrate with those roadside units. So if a agency has a bunch of deployed RSUs, we have a bunch of logic in place to be able to deploy the connected vehicle traveler information messages to those roadside units and then manage those roadside units effectively. So there's a lot of work into being able to make sure that you're pulling messages off of RSUs when they need to be, you're updating those appropriately, or you're adding them to a roadside unit. All of those roadside unit manufacturers have different ways of doing that, and Corvus is able to communicate with all of those different RSUs on the roads to do that. All right, so let's go ahead and move on to the demo. So the TIM creation and dissemination demo that I'm going to show here is about 5 minutes long. It does go into more or less, doesn't go into all the different features of Corvus, but it does talk about how to create a traveler information message from the input here or from the website side of things. So I'll go ahead and launch this demo and then talk about it a little bit afterwards. That was a brief demo of the Corvus system and really shows you how you can manually create those TIMs. You also notice that it's a bit of a process to be able to do that, and that's why we recommend integrating this with automated systems that are already in place that your TMC operators can go through. I just want to touch on some of the advantages of Corvus. So it really does focus on creating standardized messages. One of the issues that a lot of agencies or many agencies are facing are being able to distribute really relevant information and data regarding your roadways. And it's because every agency has specific scenarios where they need to address or customize data feeds for. And really, this message set, these travel information messages are really flexible enough to where it will handle customized um, message sets for different states, but be able to standardize that in such a way that everybody can read them and interpret them in the same way. So going back to that interoperability and the national push for digital infrastructure, this really focuses on us being able to put out a national effort to standardize messaging related to traveler information. Another advantage of Corvus really is to be able to integrate with AI to validate your messages. So really looking at the accuracy of your messages and trying to get as accurate a data as you can out to the public so that we can trust it. We can actually have more and more data consumers pulling from that data set to distribute to drivers on the roads. Really with the overall goal, obviously, of that Vision Zero and safety in mind. Another advantage of Corvus is really that integration with the security standards through message signing. And that's not like a super slam dunk easy thing to do. Integration on the security side and maintaining that security throughout is really difficult for a lot of agencies to handle. And Corvus really simplifies that process. We do everything on the back end, and as well as coordinate with folks from integrity security services and others. As I also spoke to this a little bit earlier, but the TIM deployment to relevant RSUs is sort of a big deal. Really looking at the business logic behind which RSUs should be receiving which traveler information messages is not a simple task. You really want to be able to deploy upstream to those geo-referenced areas that your TIM is got encoded in there. But being able to know which RSUs you want to deploy to and which RSUs currently have the same number of traveler information messages deployed there is really critical on that side. Some of the other things to really look into is TIM deployment for sending not only to the RSUs but also to the SDX. And that SDX is really the one critical backbone of how we're getting these messages out to not only connected vehicles but also standard vehicles out there that are actually just driving down the roads using either Google Maps, TomTom, or other data providers. We've got a lot of folks that are being able to pull that data from the SDX, and that's another advantage of being able to use Corvus is that integration there. We also look at the RSU status for in Corvus, so you can actually see at a quick glance the current status for your RSUs out on the roads. Let's see here. Sorry about that. In going back to that integration with the SDX, I want to just take a quick moment to talk about the situation data exchange. The situation data exchange is really a central repository for CAV messages. That includes your WZDX messages that are soon to be called connected work zone messages, Also the traveler information messages and the roadside safety messages. This is that central repository where you can have as many states as needed, hoping to get all of them on board to be able to push data, and then data distributors such as TomTom, Google, SiriusXM, and others be able to pull this data and then push that to the vehicles on the roads. So this allows both connected and traditional vehicles that can receive these messages. Now, your connected vehicles are those ones that have the OBUs installed. As we all know, the penetration rate of those are fairly low. But traditional vehicles, folks that are using your Googles, your Waze, there's quite a few of those folks out there. And being able to integrate with the SDX allows you to be able to also reach those folks. Any third party can also distribute these messages to end users. So it's a very powerful resource, and one that we hope goes really nationally. One other thing to note in here, and we think is a really cool feature of the SDX, is a traveler information skill that we built into the Alexa app that allows drivers out on the road that have Alexa-enabled vehicles, and there's quite a few of those out there too, to be able to ask the traveler information skill what road conditions look like from their current location to their destination. And what it does is it queries the situation data exchange, and it pulls those relevant traveler information message back and then reads them out to the user in real time. So it'll tell them if they're going to expect icy road conditions or snow or a sandstorm, wildfire, or if the road's closed ahead, so that they can make informed decisions going forward. This is really what we foresee as far as a nationwide deployment. And this is actually a live view, more or less a live view of the situation data exchange. And really, you can see all of the different data that we're pulling in from all states, as well as states are pushing data into the SDX. And we hope to really fill this. We've got quite a few gaps in here, even though we've got a bunch of data. We want this to be able that one-stop shop for all data consumers as well as data distributors to be able to push that data. And really what's driving that is that sort of nationwide digital infrastructure initiative that we're looking to push. Okay. So with that said, I've gone through, you've sort of listened to me enough, and we've gone through quite a few different things today. Zoritza really discussed the importance of traveler information messages and the challenges in their deployment. We talked a bit about how to create traveler information messages. And then I spoke to, the Corvus Intelligent Transportation System, including, different options on deployment there, and the features and benefits of using Corvus, as well as opportunities on using Corvus to create the TIMs. We saw that demo there too. I think that's about it. And any questions from folks?
Thanks to both Shane and Sarita. If you, those of you on the phone, if you do have questions, please enter them in our Q&A panel, and we'd be happy to answer them for you. We did have a couple questions. How does an increase in data volume impact the speed of data querying and TIM delivery?
Let's see. Sorry, can you read that one more time, Amy?
Sure. How does an increase in data volume impact the speed of data querying and TIM delivery?
Okay, that's a great question. So obviously you're going to have a little bit of impact with as data volumes drive up. The way that we typically handle that is our deployment is done through the ability to replicate through something called Kubernetes in a Dockerized deployment. And I'm getting into technical terms here. But we are able to scale quickly based on that deployment. And so we can handle a very large number of message, like data volume coming in, as well as message generation and distribution. Now, these are two separate systems. So Corvus is more or less a regional deployment that can be statewide, so you can have a large volume, but the system's built out such that with the cloud deployment, we can scale that really quickly. And then on the SDX side of things, that's where most of our querying comes into place as far as data distributors querying for data and pulling that back. And that's done in a separate system that is very robust and with a georeference database in the back end that we're able to pull data really quickly, especially because the data involved there is relatively small. So hope that answers your question there.
Yes, thanks, Shane. Another one, can an OEM directly subscribe to SDX to receive TIMs?
They can, yes. So OEMs can, anybody pretty much can subscribe to pull data from the SDX. The SDX is not something that we're charging either data producers. So if you want to push data to the SDX or consume data from the SDX, that is free and open for anybody to use. Well, not anybody. The only people that are able to publish data to the SDX are verified infrastructure owner operators. But data consumers, as long as you go through a simple verification process, they're able to pull that data.
Great. I think one more question. How does the process of generating and verifying TIMs change when using automated systems versus manual verification?
That's a great question. So the process doesn't change too much. Automation is really as you're pushing out messages through your normal systems. So say your 511 system, or as you're updating road conditions there, we are just automatically doing that in the background. So we're generating the same messages for the same road segments that you're doing within your 511 system and then deploying those. Now we do add some additional steps in there for if an agency wants to verify and validate information before they can send it out, we do provide some information there to where you can double check all of that through the website side of things on Corvus. Or we can set up stuff automatically in there to be customized to your deployment. So say you want to also push out a road closed ahead message in addition to a road closed for a particular road segment, you're able to do that through the Corvus interface.
Great. Okay, well, I think we'll give our folks a little bit of time back in their day. If you guys have any additional questions, please feel free to reach out to one of our subject matter experts here. Also, we'll have a poll that I'm going to launch with a couple questions. If you guys could take a few moments to answer those questions for us, it helps us in creating valuable webinars for you all in the future. A recording of today's webinar will be available and in your inbox in the near future. To learn more about Trihydro and our subject matter experts, please visit us at trihydro.com. Thanks for joining us today.
Thanks, everyone.
Thanks, everyone.